Assalamualaikum warahmatullahi wabarakatuh and have a good day to Dr. Jeffrey, examiner for my research project. So today, I am going to present about my research project 1. Before that, I would like to introduce myself. My name is Nurul Asyikin binti Sapuwan from EH2207K. My title for research project 1 is the effect of temperature on IgG, which is immunoglobulin solution, as a model protein for coffee-ring effect suppression. So for today, I will discover all these things from research background, problem statement, objective and methodology. So for the first part, I will brief a little bit on the overview of my research project. In research and diagnostic applications, nucleic acid and protein detection is frequently carried out using polymeric membrane of nitrocellulose. The typical method usually used for this diagnostic kit testing is we call as a dot blood immunoassay function as for detecting protein based on a specific antigen. So where it involving an antigen, preparation of antigen itself involves risk of pathogenicity, costly and need reinforcement. Therefore, what we should do? So, low concentration of antigen is preferred since it can reduce cost of diagnostic kit assembly and produce more quantity of diagnostic kit. However, low antigen concentration can cause coffee-ring effect or CRE, resulting a non-homogeneous pattern on the membrane, which disrupt results appear on the diagnostic kit and indirectly contribute to the confusing and false interpretation of result. The result of the diagnostic kit image could be confusing to the users. They might confusing to the result of the diagnostic kit. So, due to this CRE's typical issue regarding a lower accuracy and the quality of the product itself, extensive research has been conducted to suppress it by several methods has been introduced in the research. So, for my research, it will be focusing on manipulating the temperature of the protein solution at 10 degrees Celsius, 15 degrees Celsius, 25 degrees Celsius, 35 degrees Celsius and 45 degrees Celsius during the immobilization process to see how it affects CRE suppression. Then, the captured image from the protein-protein method will be analyzed by using a software known as ImageJ to interpret the surface intensity and to observe the coffee-ring effect on the membrane for each manipulated temperature. Next is research background. What is membrane? A membrane is a thin layer of material which some type of particles, atoms or molecule can pass through. In general, a membrane can be natural or synthetic. Its structure can be homogeneous or heterogeneous and can be neutral or charges. So, membrane can be classified according to different viewpoints. Membrane can come from nature that have been classified as biological and synthetic membrane. The other one that classifies membrane is by morphology or structure. So, in synthetic membrane, there are two primary categories which are organic and inorganic. Example of organic membrane is like polymeric membrane. An example of inorganic membrane is ceramic, metal, glass membrane and others. So, inorganic membrane has a higher tensile strength, outstanding chemical stability and durability to applied temperature or pressure, resulting a higher cost that this membrane prevent from being widely used in the industry. Meanwhile, for organic membrane, due to the wide range of their shapes and capability, synthetic membrane made of polymer are the main class of material used in membrane-based technology. So, for this study, it is more focusing on polymeric membrane. Due to their great processability, cheap cost, and evidence, polymeric materials have taken a prominent position in the creation of membrane and will continue to be at the center of membrane technology. Polymeric membrane are now often used in a broad variety of industrial applications such as wastewater treatment, gas treatment, drinking water treatment, and nowadays there are numerous ways using polymers in medical technology, especially in medical devices. So, polymeric membrane is widely used in the development of biosensors in medical technology. A biosensor is a device that measures biological or chemical reactions by generating signal proportional to the concentration of an analyte in the reaction. Biosensors have practical significance because of their outstanding properties in terms of flexibility, portability, and high efficiency, which provide great convenience for users and play an important role in medical diagnosis, prognosis, and healthcare. So, in this study, calorimetric biosensors are one of the types usually used in diagnostic tests as the route of detection for antigen. It functions to quantify analytes by detecting color changes that are visible to the naked eyes. So, what is diagnostic test? Diagnostic test is any kind of medical test performed to aid in the diagnosis or detection of disease via the test kit. There are various diagnostic kits available in the medical industry, such as for contagious liver disease, typhoid fever diagnosis, pregnancy test, and most recently for coronavirus diseases, COVID-19. Basically, the purpose of diagnostic testing is to detect a disease, its outlook, and its spread throughout the body. The field of biosensor is focusing more attention on immunoassay as analytical tools to quantify analytes of biological interest. Also, polymeric membrane used in an immunoassay to capture matrix and serve as a sovereign surface. There are two modes of operation of diagnostic kit that are currently used, which are lateral flow assay and dirt blood immunoassay. For my research, a dirt blood assay is used as it is a simple and a quick one that may be used to evaluate the effectiveness of antibodies and detection system. Dirt blood assay is a method that less expensive than others and allows many more samples to be analysed. Also that the polymeric membrane used for my research is nitrocellulose membrane, one of the most significant and historic cellular derivative, and it usually used in the protein blotting. Next is the problem statement for this study. Nowadays, the demand in production of diagnostic kit in Malaysia is increased by time. Since diagnostic kit using an antigen, it has a difficulty in preparing antigen. Preparation of antigen involves risk of pathogenicity, costly, and net enforcement. So, one of the best way to prepare is by lowering concentration of antigen. Even though low concentration of antigen is preferred since it can reduce cost diagnostic kit assembly and produce more quantity of diagnostic kit, however, low antigen concentration can cause coffee ring effect, resulting in non-homogeneous pattern on the membrane in a diagnostic kit. So, what is the coffee ring effect? Coffee ring effect is referred to a condition when a liquid drop that dries on a solid surface leaves a ring-like deposit behind. When CRE occurs in the diagnostic kit, it will appear like a stain, fade, or discolor on the visual of the test result obtained. The disrupted result appear on the diagnostic kit contributes to the confusing and false interpretation of the result. The result of the diagnostic kit image could be confusing to the users. Therefore, the objective of my study is to evaluate the effect of temperature on the protein solution for suppression of coffee ring effect CRE with immunoglobulin G IgG solution as a model protein. Then, the captured image from the protein blotting method will be analyzed by using a software known as ImageJ. Next is the overall methodology involved in this research. There is a preparation of membrane, preparation of protein solution, preparation of protein blotting, and lastly, image analysis. Firstly is preparation of membrane. The nitrocellulose membrane is used as an adsorbent in this study, and this membrane will cut into several rectangular 1.0 cm multiply 5.0 cm strips. Next is preparation of protein solution. For this study, immunoglobulin G solution IgG is employed as the model protein for the substitution of the real antigen. Bovine immunoglobulin BIG, in particular bovine IgG, have been studied since the 1970s for their potential effect on immunity and infection in humans, and also these immunoglobulins have a high degree of specificity so that they can assist in the destruction of specific pathogens. As my manipulated variable is temperature, so there are 5 temperature will be manipulated, which at 10 degrees Celsius, 15 degrees Celsius, 25 degrees Celsius, 35 degrees Celsius, and lastly 45 degrees Celsius. So firstly, The protein solution will be prepared for 5 ml with a fixed concentration of 3.0 mg per ml. Then the protein solution then is put into 5 test tubes for 5 different temperatures. The test tubes are then put into a beaker containing water and heated in a water bath. Water acts as a heating medium. The temperature of water in the beaker is then measured by a thermometer. For this study, it is assumed that the IgG solution in the test tube has the same temperature as the water in the beaker. This is due to prevent contamination of the heated IgG solution. The temperature of the IgG solution cannot be directly measured using a thermometer. Meanwhile, blank solution containing IgG solution is prepared in the room temperature. The blank solution is used as reference for the observation for the co-feeding effect. Next is preparation of protein blotting. For the protein blotting, 1 microliter of the blank solution and 1 microliter of the sample solution is dotted at the nitrocellulose membrane by using micropipette. The drop at the membrane is let to air dry between 5 to 15 minutes for the action of membrane with protein to occur. Then the membrane will be immersed in ponchau S for a few minutes and the effect of co-feeding start to appear. We use ponchau S in this study as a dry solution. After that, the membrane is rinsed with distilled water to remove any impurities and dry again at the room temperature. The step is repeated and the result is compared at 4 other manipulated temperature. Next step is image analysis. The nitrocellulose membrane with the spotted solution is scanned by using Epson scanner and the resolution applied to the high quality image. These images are then analyzed using a software known as ImageJ, where it provides tools to interpret and analyze the characteristic of the surface intensity, color and also the co-feeding effect on the membrane. So for lastly, my research is to control the final deposition pattern of an evaporating droplet without changing its composition. It may be achieved by altering the dynamics of internal flow using external forces, which is temperature that I use in this study, without using a chemical additive. The temperature is one of the factors that can help to obtain uniform or homogeneous patterns of color droplet for CRE suppression. I think that's all from me. Thank you, Doctor.